Next topic is types of formulae. Okay, we can represent organic compounds by using 4 different types of formulae: molecular formula, structure formula, condensed formula, and dot and cross formula. First type of formula is molecular formula. You people have already studied it in chapter number 1 of 9th class. Okay, the definition is the formula which represents the actual number of atoms in one molecule of the organic compound is called as molecular formula. For example, you can see over here, first organic compound is methane. The molecular formula of methane is CH4. Now what this formula is showing, it is telling you that the methane is formed of carbon and hydrogen. And second thing that it is telling you is that one carbon atom and 4 hydrogen atoms are combining together and they are forming methane. So a molecular formula tells you which elements are present in that molecule of the organic compound and what is the number of atoms of these elements. Got it? Like you can see over here, the example of butane is also there. Butane is formed of carbon and hydrogen. 4 atoms of carbon and 10 atoms of hydrogen form butane. Got it? Next type of formula is structural formula. Okay, definition of structure formula is that structure formula of a compound represents the exact arrangement of different atoms of various elements present in a molecule of a substance. Now, through molecular formula, we know which elements are there and how many atoms are there, and structure formula tells you how these atoms are arranged with each other. Okay, for example, in the structure formula, single bond is represented by a single line, double bond is represented by a double line, by 2 lines, and a triple bond is represented by 3 lines. Okay, now look at this first example. Over here, this is the formula of butane. Butane is composed of 4 carbon atoms, and you can see that these 4 carbon atoms are arranged in a straight chain with each other. The valency of carbon is 4. Okay, so it should form 4 total bonds. You can see that this first carbon atom is forming one bond with the other carbon atom, and now 3 more bonds are to be formed because 3 electrons are there that are unpaired. So these 3 bonds will be formed with 3 hydrogen atoms, and in this way tetravalency of carbon will be satisfied. You can easily write the structure or formula of a organic compound if you know the number of carbon atoms in it. It is butane. ANE at the end of the name indicates that it is a saturated compound. All the bonds in this compound should be single covalent bonds. Okay, so first what you will do is you will arrange the carbon atoms in straight chain, and then you will start attaching hydrogen atoms to them. Okay, you can see that in the second carbon atom, one bond is formed with one carbon atom and the other bond is formed with the other carbon atom. Now 2 more bonds are to be formed, so it will combine with 2 atoms of hydrogen, and in this way it will satisfy its tetravalency. So now you can see that the first carbon atom is joined with 3 hydrogen atoms, the second carbon atom is joined with, these are the 3 hydrogen atoms that are joined to the first carbon atom. The second carbon is joined with 2 hydrogen atoms. Okay, the third is also joined with 2 hydrogen atoms, and the last carbon atom is joined again with 3 hydrogen atoms. Got it? This was the structure of a N-butane, means straight chain butane. Now an organic compound may have more than one structural formulae, more than one type of arrangement of atoms. You can see this second structure of butane. This butane is called as isobutane because here the carbon atoms are not joined in a straight chain. 3 carbon atoms are forming a straight chain and the 4th carbon is forming a branch along the straight chain. Such type of compound is called as branched chain organic compound, and its name starts with iso. Its name starts with iso. So it is isobutane. Got it? And then the hydrogen atoms are attached as the in the same way as we have attached in this first compound. Okay, 3 hydrogen atoms are attached to the first carbon, 1 is attached to the second carbon because it is forming 3 bonds with 3 carbon atoms, and 3 hydrogens are attached with the third carbon, and you can see with the fourth carbon also 3 hydrogens are attached. Got it?